Hello everyone, welcome to my YouTube channel Physics Junction by Rakshitha, your one-stop destination to learn physics in a simple way. For more videos, please like, subscribe and share my YouTube channel. Let us begin with today's topic, Coulomb's law, the fundamental law of classical electromagnetism. Coulomb's law describes how two electrically charged objects interact when they butt near each other, and it tells us that electrostatic force between 2 point charges depends on two things, and the first one is how large the charges are and how far apart they are. So greater the charges, the stronger the force, and the farther apart they are, weaker the force, and vice versa. It means Coulomb's law tells us the force between two charges when they are brought near each other. It states that electrostatic force between 2 point charges is directly proportional to product of the charges and inversely proportional to square of the distance between them. Let us see the formula for Coulomb's law by considering 2 point charges Q1 and Q2 separated by a distance R in vacuum, and the force between them is given by F is equal to K into Q1 into Q2 divided by R square, where K is Coulomb constant. The value of K is 1 divided by 4 pi epsilon naught, and it's a universal constant. The value of K is 8.99 into 10 power 9 Newton meter square per Coulomb square. Therefore, F is equal to 1 divided by 4 pi epsilon naught Q1 into Q2 divided by R square, where F is the electrostatic force between 2 point charges measured in Newton, and Q1 and Q2 are the 2 point charges measured in coulombs, and R is the separation distance between them measured in meter, and K is Coulomb's constant. Then the limitations of Coulomb's law. Coulomb's law is powerful, but it has boundaries. The law strictly applies to point charges only. It gives accurate results only when the charge bodies are very small compared to distance between them. Then the charges must be stationary. Coulomb's law describes electrostatics, that means charges at rest. When charges move, magnetic effects arise and the full frame of electromagnetism is needed. And then vacuum or air. The constant K given here applies to a vacuum. In another materials, for example dielectrics, the force is reduced by a factor called the relative permittivity. For more than two charges, the net force is found by the vector addition. The superposition is required for many charges. This principle of vector addition is called principle of superposition. What's the superposition of charges? We can calculate electric force between any two charges by Coulomb's law. Now, let us consider a system of n stationary charges. Then, what's the formula to calculate the forces on n charges? So, we can calculate this by superposition of charges. It's verified that force on any charge due to number of other charges is the vector sum of all forces on that charge due to other charges taken one at a time. The individual forces are unaffected due to presence of other charges, and this is termed as principle of superposition. The principle of superposition states that the net electric force acting on point charge due to system of charges is equal to the vector sum of individual forces exerted by each charge acting independently. To understand this concept, let us consider system of three charges Q1, Q2 and Q3. Okay, firstly, we will find out the net force acting on Q1. The force on charge Q1 due to other charges Q2 and Q3 can be obtained by performing vector addition of forces due to each one of these charges. The force on charge Q1 due to charge Q2 can be denoted by F12 from Coulomb's law, the force on charge Q1 due to charge Q2 is equal to 1 divided by 4 pi epsilon naught into Q1 into Q2 divided by R12 square into R12 cap, where R12 is the distance between the charge Q1 and Q2 and R12 cap is the unit vector from the charge Q2 to Q1. In the same way, we can find out the force on Q1 due to Q3 denoted by F13. Therefore, the force on charge Q1 due to Q3 is given by 1 divided by 4 pi epsilon naught into Q1 into Q3 divided by R13 square into R13 cap. Now, by applying principle of superposition, we can find out the net force, that is vector force on charge 1 is equal to vector force on charge 1 by charge Q2 plus vector force on charge 1 due to charge Q3. Means F1 vector is equal to F12 vector plus F13 vector. Now, by substituting the expression of F12 vector and F13 vector in the above equation, F1 vector is equal to 1 divided by 4 pi epsilon naught into Q1 into Q2 divided by R12 square into R12 cap plus 1 divided by 4 pi epsilon naught Q1 into Q3 divided by R13 square into R13 cap. Since here 1 divided by 4 pi epsilon naught and Q1 are common factor, let us take them outside the bracket. That is F1 is equal to Q1 divided by 4 pi epsilon naught into Q2 divided by R12 square into R12 cap plus Q3 divided by R13 square into R13 cap. If additional charges Q4, Q5 up to Qn are present, the same process gives F1 vector is equal to Q1 divided by 4 pi epsilon naught into Q2 divided by R12 square into R12 cap plus R3 divided by R13 square into R13 cap plus up to Qn divided by R1n square into R1n cap. Or we can write in summation form also. In summation form, we can write F1 vector is equal to Q1 divided by 4 pi epsilon naught summation from I is equal to 2 to n Qi divided by R1I square into R1I cap. This is the mathematical expression of the principle of superposition of charges. This formula of principle of superposition is used to calculate the net force when multiple charges are present, and Coulomb's law forms foundation for understanding electric fields, electric potential and electrostatics. Thank you for watching. For more videos, please like, share and subscribe to my YouTube channel.